Hello, I'm Jemmy, and today I am going to be giving you an overview on Foody Duty, an image classification model that can differentiate between 48 different Thai foods. And without further ado, let's get into our first topic. Our first topic is why I created Foodie Duty, which is our problem statement. So when I go to other countries like China and then I'm not familiar with their food or culture, this means that I don't know how spicy their food is not. So if you want to see what I encountered, then here's a menu, like so. And you can see that all the dishes are various colors, and I depend on that color to show me if it was spicy or not. So the more red it was, the more spicy it was. Well, at least that's for me how I check it. And the less red it is, meaning like yellow or and pale, then I would assume that that one was not spicy. However, one time I saw a dish that was yellow, pale, and looked very innocent. However, when I bit or like I dived into it, it was very spicy. So I can't always rely on this sense to tell me if it was spicy or not. The second thing is that I don't know the ingredients. So I'm allergic to shrimp, and if I eat shrimp, I have my allergies. So if I have eat shrimp in a dish, then I would get my allergies. However, in here, I couldn't tell if there's shrimp or not, since the image might not show the shrimp and might conceal it. So yeah, those are the two things I have to worry about everywhere I go because I'm not familiar with their food or culture. Now, the second topic is my baselines. So I found a link that I'll show you later by New in Net, or NU in Net, and they have a image classification model on Thai food on the smartphone, so using neural networks. So yeah, that is their model, and you can see that me and their mine, sorry, theirs and mine accuracy are pretty different because their accuracy is not as great as mine's, because if you look at top one, which we are going to use to compare, since mine's is also top one, so as you can see, it's not as great as mine's is. However, the that is one of the pros of mine's. But however, the con is that if you look at the model size over here, their model size for their two best models are 3 megabytes. So that is my con that I have right now. Since my model is 83 megabytes, it has a drastic difference. So you either sacrifice the accuracy for the model size or the model size for the accuracy. And that's what I went to. So if they were to have a contest with me on who would load faster on a smartphone, theirs would probably win. And yeah, that is the pros and cons and baselines. Now let's move on to our third topic, which is how I prepared my data set. So first is I didn't want to manually get all of my images from Google, so I decided to look for an image scrapper, and I found that in NumPy. And here is what it does. So it scraps images from DuckDuckGo like so, and then once I actually looked inside the files for my data set, it was not accurate at all. So I had to go clean it manually, which I was going to do anyways. I just didn't realize that there's going to be this much images that were unusable. So once I cleaned them, there's only 70% of the images left. And so since I need to fulfill it to 100%, I handpicked the rest from Bing, Google, and YouTube. How I uh, per- how I did it for YouTube was that I just screenshotted images from the video. And yeah, that is my data collection. After that, however, I wasn't done. I went and created or followed a tutorial on how to create a similar image program that will help you find similar images so that a data leakage wouldn't happen. And then that's what I did too. And yeah, so I found the similar images. I deleted some images and then I replaced them with other images so that my data set would be complete. However, to make sure that the images that I replaced were not already inside the dataset, I had to search with a different keyword. So instead of searching in Thai or Thai karaoke, I searched in English. So yeah, that's what I did. And then understanding my data, exploratory data analysis. So this one, I just experimented with augmentation. So I tried each one of them out to optimize my error rate. And yeah, so for the first one, there's none. As you can see, it's 6. And for the rest, it's actually quite the same, 5, 6, 5.4, 5.5, etc. However, the two that really stands out is size 512, which is to resize my image to 512 pixels by 512 pixels, and performing the standard fast AI algorithm on it, not algorithm, augmentation on it, and it got me down to a whopping 2.8% error rate, which is really good. And then the second one that stands out is max zoom equals to 2. Max zoom equals to 2 is, you might have guessed, just zooming your image in 2 times. So it's basically making it a little bit more better resolution, I can say. And then that's what it did. And it got me down to 3.9% error rate, which is also pretty good, but not as good as my 512 size. And that is understanding my data. And yeah, so my other one is now my second to last one. I'm pretty sure is testing and understanding the results of my model error analysis. So this one I fine tuned it. This is my data block. I used standard augmentation 512 because I decided that it was really good. So I was going to continue with it. And yeah, this is the result of my fine tuning. You can see that the error rate has got to 3.1%, which was slightly higher than the other one, but it's still pretty good. So yeah, I fine tuned it 9 times, and then this was the result. And here is the data block I used for testing my model on the test file, and here it is. And then the result, the top loss I can say is this. It is uh pretty, how you call it, you can say reasonable that my AI got it wrong. So if the first one, we can see why it got it wrong. The actual is 46, which is musete, and then number 5 is gang masaman kai, right? So you can see why it got it wrong. My the photo was a really close up of the sauce itself, and then that is not really like the main point of musete, which is only the pork, right? Only the pork part. However, for gang masaman kai, the soup is the main thing, since that is it's a stew. That's it. So since it took a really close up of it, and the colors are pretty much the same, orange and yellow, my model thought that this was gang masaman kai. So it had a 97% probability rate of gang masaman kai. But you can see that the errors are pretty reasonable too. For the second one, if you ever ate these two dishes, you'll know that they are almost the same thing. It is between, so it's actually cow kamu, but then my AI thought it was, where is it? Oh, number 10 is kaipalo, and these two are very similar. They both have a sweet brown sauce, and you can basically, if you would like to taste the sauce, you would you wouldn't know if it was from Kaukamu or Kaiplo. And then yeah, this was the reason why I got it wrong. And another reason was that you can't really see the pork. And usually sometimes in Kaukamu there's gonna be Kaiplo too. And this one you can clearly see the egg while you can't really see the pork too much. And yeah, this is why this one got it wrong. And then the last one is between Khao Pat Gung and Khao Pat. It is actually Khao Pat Gung, but then my model thought it was Khao Pat Tamada. So the reason I think this got it wrong was because usually on Khao Pat Gung there's going to be a lot of shrimp displayed around the dish because that's usually the main point of their dish, and they want to like show the customers that you get really big shrimp if you order this. However, this one, the shrimp, it was concealed beneath some vegetables up here. You can't really see the shrimp. So and then you can see a lot of rice. Um, so that is why my AI thought that this is cow pie. Okay, now my last topic is how I deployed Foody Duty. So the deployment process, and this is pretty simple, I can say. Well, simple for my binder. So as I said, my binder, I decided to deploy my Foody Duty on my binder because it was really simple and I just had to follow fast AI. And it was the deployment process was like you just upload. Well, you didn't upload. You copy it and paste your GitHub repository link into my binder, added Viola, and then made changed it to main, the branch to main, and then just click a launch or something. I forgot because it was a long time ago. You just have to click launch, and then it will just create it for you like that. However, it was really slow since my model is really big, so it was really slow till the point that I decided to change it to Heroku plus Streamlit, and this was much harder uh, than my binder because of two reasons. One, the deployment process is really complicated, and two, Fast AI didn't go on Heroku or Streamlit. so you can't really do too much. However, decided to do some research, and then I found some code to use for pushing it into Heroku using Streamlit, and then I used that code and pushed my Foody Duty into Heroku using Streamlit. And yeah, that is my Foody Duty explained to you. I hope you enjoyed this video. Bye.